Good afternoon, learners. Welcome to the platform, Black Slides Online. My name is Mr. Pochilola once again, your teacher on this platform. All right, I'd like to share with you this workbook. This is a physics workbook which I personally prepared for my students. Those who are doing physics from 4, I made this workbook for them so that they can practice on their own, and of course they have their teacher to check their solutions. In so doing, they are giving themselves confidence in answering physics questions. So the workbook contains all the topics in Form 4 physics. Right, they are exam style questions. Let me urge you to get a copy of this. Get a copy of this so that you can have this copy as you're going back to school in January. Have this printed and take it along with you to school and practice. All right. So it has all the topics put together in form of introductory notes and questions. The questions are exam style questions which will give you confidence, self-confidence in approaching physics questions, especially from 4 topics. All right, so if I were you, I would grab this, I would ask for this so that you print it and take it to school with you as you are going back in January. All right, so in order to get this, just text me on the number that is shown here. I'll be glad. I'll be excited to share with you so that you can print it and take it to school as you're going and practice on your own. Even if you are not going to a formal school, you are studying at home on your own, I would advise you to have this workbook so that you can practice. You can practice on your own and have me to check your work. So it has all the topics, introductory questions, introductory notes, and the questions, topical questions, which are exam style questions for you to practice on your own. And have your teacher to check to check your answers and make necessary corrections where they are due. Very, very important. So it has all the topics in one booklet. It is going to be exciting to have you ask for this pamphlet. I'll be glad to share it with you if that's what you want. All right, so once again, welcome. For now, I would like us to go through a topic called the electronics. Electronics. It's one of the final topics in MSCE physics. All right, so here we go. We have the topic called physics or digital electronics. All right, so the syllabus requires that in as far as this topic is concerned, you should be able to discuss semiconductor devices. You should be able to discuss electronic components and their uses, describe analog and digital circuits. You should be able to describe the operation of basic logic gates. So these are the key areas that you need to master as far as this topic is concerned. Welcome once again. So once again, let me urge you to get a copy of this workbook so that you can practice on your own and have your teacher to check check for the correctness of your answers. Or if you are not going to a formal school, you can still get it, and let me check the correctness of your answers. Once again, my name is Mr. Pochilola, your teacher on this platform. Alright, if you are learning in our main class, Black Slides online class, make sure you have a copy, this copy. If you are learning in our main class, this copy is also available for download. You can download it and practice the questions. All right, so the first question is saying, these are just study questions. As you're studying your notes, you should be attempting to answer these questions. All right, that's very, very important. All right, so define conductors. For the sake of this topic, we shall define conductors as materials. So all materials that allow electric current to flow through them are called conductors. Your examiners will require you to know the examples. So in this case, metals such as copper. Think of all metals such as copper, silver, zinc. All these are examples of conductors. All right, conductors. All right, so these are conductors. All right, what about semiconductors? Right, we define semiconductors. Semiconductors are defined as follows. Right, what are semiconductors? Semiconductors are materials. These are materials whose conductivity lies between that of conductors, right? Conductors and the insulators. So these are not superconductors. They are not very good conductors. They are not very bad. They are materials whose conductivities lies between that of conductors and the insulators. All right, again, you should be able to give examples. Examples are silicon. Remember silicon, these are elements that you find in the first group of the periodic table, and germanium. Germanium. All right. So silicon and the germanium are examples of semiconductors. All right. So for each type of conductor or material, you should be able to give examples, at least 2 examples. Welcome, learners, to the platform. This is Black Slides Online, a platform where you learn the sciences. All right. In case you are new to the channel, consider subscribing to the channel so that every time we upload a new video lesson, you are notified in time, right on time. All right. So insulators, on the other hand, are materials. These are materials which do not allow electric current to flow through them. Current to flow through them. Alright, materials which do not allow current to flow through them are called insulators. Again, you should be able to give examples. So examples of insulators are paper, okay, plastic, rubber, and so on. So for each type of material, you should be able to give an example. So we are saying, from this we are saying, conductors are materials that allow electric current to flow through them. For example, metals, all metals. Think of all metals. Think of metals like copper, silver, iron, zinc, okay, magnesium, mercury. Any metal you can mention is an example of a conductor. Semiconductors, on the other hand, are materials whose conductivity lies between that of conductors and the insulators. These do not fully allow current to flow through. They also do not fully prohibit current from passing through. A little bit of current would flow through them. Therefore, they are called semiconductors. Examples are silicon and germanium. Remember, silicon and germanium are elements that you find in the periodic table, in the fourth group of the periodic table. Germanium. All right. So that's basically what we are saying. Unless you have questions, so far so good, I believe. All right, I'm just showing you how good this workbook is. It helps you to practice, to practice. All right, to practice, to build confidence for yourself. All right. Next, let's look at the band theory. All right, so the question here is saying, number 2, give the meaning of the following words. The band theory. The band theory states that it's just a statement. All right. The band theory is a statement that says that, all right, when two atoms are brought close together, are brought close to each other, their energy levels split. That's what the band theory states. Split into smaller bands, smaller energy levels, which are called bands. Yeah, so that's the energy band theory. The band theory, what it states. We are saying when two atoms are brought close to each other, their energy levels split into smaller energy levels, which are called bands. All right, the conduction band. The conduction band is simply a region in the material which is mostly which is mostly empty, and contains, this is mostly empty. By empty we mean without electrons, right, where it allows current to flow through. A better way to put it is to say it is a region in a material. It is a region in a material. So it is a region in a material that contains, so this region contains free electrons, free conducting electrons. So that's the conduction band. The valence band is a region in a material. This is a region in a material which contains the majority of the electrons. Of the non-conducting electrons. All right, so the electrons in the valence band are not so free to conduct electricity. In order for them to conduct, they must transfer, they must migrate from the valence band to the conduction band. All right, then we have forbidden gap. The forbidden gap, this is simply the region between this is the region between the valence band and the conduction band, in which electrons are not allowed to be, in which electrons are not allowed to be found. It's like out of bounds for electrons. This region does not contain electrons. Electrons are not allowed to be there. All right. Explain two types of semiconductors. So there are basically two types of conductors. We have what are called intrinsic semiconductors, and extrinsic semiconductors. Make sure you know the difference between the two. Remember that intrinsic semiconductors are pure semiconductors such as silicon and germanium, while extrinsic semiconductors are conductors that have been doped or to which impurities have been added in order to improve their conducting properties. Doping is a process or just addition addition of impurities to intrinsic semiconductors, intrinsic semiconductors, in order to improve their conductivity, Right. We shall get the details of doping later. Depletion layer. The depletion layer is a region, empty region, between the N and the P, between the P type and the N type. Semiconductors. Say that. All right. Forward biased diode is a diode which conducts only in one direction. Conducts current in one direction is called forward biased, and this happens when the cathode of the diode is connected to the negative of the battery, and the anode of the diode is connected to the positive of the battery. Then it becomes a forward biased mode. All right, so I'd like to leave you now. You can continue with the rest of the questions in your own time, and please consider getting this pamphlet so that you can practice on your own. All right, my name once again is Mr. Pochilora, your teacher on this platform. Wishing you a wonderful Saturday evening. Meet again later.